So these are the next questions which we are going to do. You may note down the questions and then we will solve. We'll start with the question number 10. Three resistances are connected to a 12-volt battery as shown. So three resistances are connected to so this is a 12-volt battery and this is the ammeter, and three resistances, two are in parallel and the parallel combination is in series with the 8 ohm. The parallel combination of 12 and 6 ohm resistance is in series with the 8 ohm resistance. So our first question is, what is the current through 8 ohm resistance? First is current through 8 ohm resistance. So the current through the 8 ohm resistance is nothing but the total current in the circuit, because all the current which is coming, that same current is passing through the 8 ohm resistance. So we have to find the total current. So total current is equal to, we know V is equal to IR and V upon R is equal to current, where V is the EMF of the cell and R is the effective resistance or total resistance. So R effective, we have to find the total resistance. So total resistance is 8 ohm plus 12 parallel to 6. 12 ohm parallel to 6 ohm. So 8 ohm and this is in series and 12 and 6 are in parallel. So parallel of 12 and 6 is 1 upon R equivalent is 1 upon 12 plus 1 upon 6 is equal to 1 upon 12 into LCM is 12. We get 1 plus 6 2s are 12, 3 upon 12. So R equivalent comes out to be, R equivalent is 4. 3 4s are 12. R equivalent is 4. Therefore total is R total effective resistance is 8 plus 4 is equal to 12 ohm. Total is 12 ohm. Therefore current comes out to be, current through 8 ohm resistance is equal to the main current or the total current, which is equal to V upon R. So V is 12, V upon R 12 upon 12 ampere is equal to 1 ampere. So 1 ampere is the current. So here 1 ampere of current is coming through the resistance 8 ohm and 1 ampere is the total current. Second is, what is the potential difference across parallel combination of 6 ohm and 12 ohm? So we have to find the potential drop here. We have to find the potential difference here. So here we have to find the potential difference V across the parallel circuit. So we know that the R equivalent is the total resistance here is, so this can be written as, the circuit can also be drawn as here 8 ohms and the equivalent of 12 and 6 comes out to be 4 ohm. So this is equivalent to 4 ohm resistance. This combination is equal to 4 ohm resistance. So here we have to find the potential drop. So what is I? Same current I, 1 ampere is coming, same 1 ampere is coming through 4 ohm or from the parallel combination. So second potential drops, we have to find the potential drop is equal to I into R. I is 1 and R is 4 ohms. So R is 4, therefore V comes out to be 4 ohms, 4 volt. So V is 4 volt, potential across the parallel combination is 4 volt. This is the second part, and third part is, what is the current through the 6 ohm resistance? So we have to find the current through the 6 ohm resistance. So next is current through the 6 ohm resistance. So current is equal to V upon R. So what is R? R is 6 and what is V? V is the potential drop across 6 ohm resistance. So potential drop across 6 ohm is same as the potential drop across 12 ohm. It is same as the potential drop across the whole combination. So potential drop across the combination we have calculated as 4 volt. Therefore this is 4. So current comes out to be 4 upon 6 ampere. So 2 2s are 4, 2 3s are 6. So 300 and 20 36 jar. So it comes out to be almost 0.66 amperes. 0.66 amperes is the current through the 6 ohm resistance, and if they are asking the current through the 12 ohm resistance, it will be current through 12 ohm resistance will be simply 1 minus 0.66 ampere is equal to, because total current is 1 ampere. Now I'll move to the next question. So our next question is question number 11. Six resistances are connected together as shown in the figure. We have to find the equivalent resistance. We have to find equivalent resistance. So these are the six resistances. Six resistances are connected as shown. So these are the six resistances between point A and B. So we have to find the equivalent resistance between point A and B. Means in spite of all these six resistances, what should be the value of that one resistance which should be between A and B, whose resistance is equal to the resistance of this whole combination. So that we have to find. So this is 2 ohm, this is 10 ohm, this is again 2 ohm, this is 3 ohm, this is 5 ohm, and this is again 5 ohm. So we have to see how we look into the circuit. So we'll start from point A. So when we are starting from point A, suppose current I is coming. Suppose current I is coming, that same current I will pass through the 2 ohm resistance, and that current I will get divided. After coming here, it will get divided into two parts, I1 and I2. I1 and I2. Now, same current I1 will pass through resistance 2 ohm, same current will pass through resistance 3 ohm, and that same current I1 will also pass through the resistance 5 ohm. What does it mean? Because same current is passing through 2 ohm, 3 ohm and 5 ohm, it means 2, 3 and 5 ohm resistances are in series. And we can also see here that this whole combination, this is a one combination which is in series. So these three are in series. So first of all, what we will do? We will make the equivalence of these circuits. We will make the equivalence of this circuit. So we will get A, step by step we will see. Then we will come to know how the circuit is reducing. We have to slowly reduce the circuit. Then we have here we have a 10 ohm resistance, and here we have a 5 ohm resistance, and we have 2 ohm, 3 ohm and 5 ohm in series. Because these are in series, then total resistance will be 5 plus 3 plus 2 means 10. So this is 10, total resistance is 10. So in series, this is 10 ohm. This is again the sum of 2, 3 and 5 is 10 ohm, because these are in series. Now after we have find the equivalent of 2, 3 and 5, now we can see here clearly that this 10 ohm resistance and this 10 ohm resistance both are parallel to each other. Why? Because if current is coming I, so I1 will go, I2 will go here, I1 will go here. The current is different, but the potential drop against both is same, because both ends are directly connected to the same point. So this end is also connected with point P, and this end is also connected with point P. Similarly here, this end is connected to point Q, and this end is also connected to the point Q. So here you have to see one thing. See, this is point P and this is point Q. So there are two ways to how two resistance can be directly connected. So if we are connecting it like this, so if we are connecting it like this, so here also all the three resistances are directly connected. All the three are directly connected. And if we are drawing a diagram like this, So here also all the three are directly connected. So don't get confused from the diagram. These two are directly connected to the same point because this is a wire of negligible resistance. We assume the wire is of negligible resistance. There is no resistance of this wire, so these 2 points are connected with each other. Similarly, these 2 points are also connected. So both the ends of these two resistances are connected with each other, so they become in parallel. So now they are in parallel combination. Therefore, we'll find A, and there is 2 ohms. This is 2 ohm resistance, and now the parallel combination of 10 and 10. Parallel combination of 10 and 10 comes out to be, it will be 1 by 10 plus 1 by 10 is equal to 1 by R equivalent. So we have 10 is the LCM. So 10 upon 2 is the 1 by R equivalent, or we get 5, R is equal to 5. So the equivalent resistance here is 5. 5 ohm is the equivalent resistance of these two parallel combinations. Then here we have 5 ohm. Now we can see 2 ohm, 5 ohm and this 5 ohm and this 5 ohm. These three are in series. As we go on reducing the circuit, we come to know these are in series. So because these are in series, we will get A and B equivalent to one resistance whose equivalent resistance is 5 plus 5, 10 plus 2, 12. So equivalent resistance is 12 ohm is the equivalent resistance between the 2 points. So this is how we find the equivalent resistance. Here also we can directly see the three are in series, and this series combination is in parallel with the 10 ohm resistance, and the parallel combination of 10 ohm resistance and the whole circuit is in series with 2 ohm, this parallel combination, and this. You can also write this as, this combination can also be written as, we have 2 ohm, then we have a parallel combination, then we have a parallel combination, then we have a 5 ohm resistance. We have a 5 ohm resistance, and this is a parallel combination of 10 and series. In series there are 2, 3 and 5 in series. So we can also write it as like here, like this, 2, 3 and 5. These are in series, and this is the equivalent circuit. This is how this circuit looks like. So you have to learn, you have to understand how the connections in the circuit are made. Now we will move to the next question. Our next question is question number 12. So we'll move to question number 12. We'll move. The equivalent resistance of the circuit is for calculate the value of X. We have a circuit. So we have a circuit. So the resistances are 5 ohm. Now this is 8 ohm. This is 4 ohm, and this is X ohm. This we have to find. So equivalent is given as, R equivalent is given as 4 ohm. We have to find the value of X. So we have so if the current is coming I here, it will get divided I1 and I2. That same current I1 will flow through 5 and X. Same current will pass through 8 and 4. Therefore 8 and 4 are in series, and 5 and X are in series, and the series combination is in parallel to each other. So this diagram can be, circuit can be reduced as two resistances. These two resistances are 5 plus X, the series combination, and 8 plus 4 is equal to 12. So the parallel combination of 5 plus X and 12. So R equivalent is 1 by R equivalent is 1 by 5 plus X plus 1 by 12. So we'll take the LCM. We get 5 plus X into 12. So if we don't know the value of X, the LCM will simply be we'll simply multiply the both terms. to make the denominator same. So here we will get 12 plus 5 plus x. So this is equal to 17 plus x divided by 12 5s are 60 plus 12x, and this is given as 4 x ohms. This is given as 4 ohms. So the equivalence is given as 4 ohms. So so from here we may solve it. So we'll get 17 plus x is equal to 60 plus 12x into 4. So you get 7 plus x is equal to 6 4s are 24, 240 plus 12 4s are 48x. So 5 plus 1 by 5 plus x divided by 1 by 12. So it is, sorry, this is equal to r, this is equal to 1 by r equivalent. This is 1 by r equivalent, so this will be 1 by 4. So this is 1 by 4. So we'll get 4 will be divided here, or 4 will be multiplied here. 4 multiplied to the other side. So we'll get here so 17 into 4. So 17 into 4 will get 68. 68 plus 4x is equal to 60 plus 12x. Now we'll do 4 will come to that side. 68 minus 60 is 12x minus 4x. So 68 minus 60 is 8 is equal to 12 minus 4 is again 8x. So x comes out to be 1. X comes out to be 1. So value of this resistance is 1 ohm. This is the value of x. Now we'll move to the next question. So I'll move to next question. Our next question is 13th question. Three resistances 6, 2 and 4 ohm respectively are joined together as shown in the figure. So we have 3 resistances. So there is a battery of 6 volt and 3 resistances are resistance 1 and 2 and 3. 3 resistances, this is 6 ohm, this is 4 ohm and this is 2 ohm. These are connected as shown. So here is an ammeter here. So what we have to do, the resistances are connected and battery is of EMF 6 volt. The effective resistance of the circuit, we have to find the effective resistance. So from here we can clearly see current I is coming from here. I will be divided into I1 and I2. The same current I2 will flow from 4 ohm resistance and 2 ohm resistance. It means the circuit can be drawn as, this same circuit can be drawn as, so here is an ammeter. So here is 6 ohm resistance. This is 6 ohm resistance and there are 2 resistances 4 ohm and 2 ohm. 4 and 2 ohm are in series and that series is in parallel with the 6 ohm resistance. Because the 2 ohm is here or here, it does not matter. Because this is a conducting wire, we can draw 2 ohm here also. So now we can clearly see these are in series. So from now we can see we have 6 ohm resistance and here we have 4 plus 2 is 6 ohm resistance. And therefore 2 6 ohm resistances are in parallel to each other. So R equivalent will be 1 by R equivalent is 1 by 6 plus 1 by 6 is equal to 2 by 6. So R equivalent is equal to 3. R equivalent is equal to 3 ohm. This is our first part. R equivalent as 3 ohm. current drawn from the circuit. So we have to find the current from the circuit. So current is equal to V by R is equal to V is 6 volt and R is 3 ampere, 3 ohms. So current is 3 2s are 6. 2 ampere is the current drawn from the 2 ampere is the current drawn from the circuit. Now we'll move to the next question. These all are previous year questions which are asked in the ICSE board exams. So next is question number 14. A cell of EMF 1.5 volt and internal resistance 1.6 is connected to two resistances of 4 ohm and 2 ohm, 20 ohm, and we have to find. So we have a battery whose EMF is 1.5 volt is the EMF, and also we have an internal resistance IR of 1 ohm, and we have two resistances which are in series. These are 4 ohm and 20 ohm. So this is we have the internal resistance of the battery as 1 ohm. So we have to attach this 1 ohm in series with the other resistances. The internal resistance is always connected in series with the external resistances. So this is this is how we'll draw the circuit. So this is the battery of EMF 1.5 and this is the internal resistance of 1 ohm and this is 4 ohm and this is 20 ohm. Now we'll have to find the current in the circuit. So current is V upon R, where V is 1.5 volt, and what is R? R is the total resistance. Total resistance is 1 ohm plus 20 ohm plus 4 ohm in series. So 20 plus 4, 24 plus 1, 5. 25 is the total resistance. So 15 upon 250. This comes out to be 5 5s are 25 and 5 3s are 15. Again we can write 5 10s are and 5 8s are. We have 30 we have and 6 are 30. So 0.6 volt, 0.6 ampere. So current in the circuit is 0.6 ampere. 0.6 ampere is the current in the circuit. Our first part. Now is the second part, potential difference across 4 ohm resistance. So potential difference across 4 ohm resistance is V is equal to I into R. So I through the 4 ohm resistance is 0.6 ampere. So 0.6 and resistance is 4 ampere. So 0.6 into 4 is 0.24 volt. 0.24 volt is the potential drop across the 4 ohm resistance. The potential drop across the 4 ohm resistance is 0.24 volt. Next is voltage drop when the current is flowing. So voltage drop, what is voltage drop? Voltage drop is the potential which is dropped inside the cell. So the potential inside the cell, voltage drop, potential inside the cell is dropped across the 1 ohm resistance. So V is IR. I is again, it is same because all are in series. So same current is flowing 0.6 ampere. And what is the voltage drop? Drop is across 1 ohm resistance. So it is 1. So 0.6 volt is the internal voltage drop. Potential difference across the cell. Now we have to find the potential difference across the cell. Potential difference across the cell. Now the potential difference across the cell is working. So there is a potential drop across the cell, means in the outside circuit. The potential drop in the outside circuit is total current upon total current into resistance. So total current is 0.6 and total resistance is which is the total resistance? Total resistance will be the outside resistance, not the inside resistance, because inside is the EMF. We have to find the terminal voltage here. Here potential drop across the cell when it is working means the terminal voltage. So total outside resistance is 20 plus 4 is 24. So 0.6 into 24. 0.6 into across the cell. 0.6 into 24, or we can simply do, we can do this also, or we can simply do another thing also. Terminal EMF is equal to terminal voltage plus the voltage drop. Therefore, EMF minus the voltage drop, internal voltage drop is equal to terminal voltage. EMF is 1.5 and voltage drop is the voltage drop across 1 ohm resistance, which is 0.4 volt. We can simply write 1.5 minus 0.6. This also we can do, or we can multiply 0.6 with 24. So we'll get, what we'll get here, we have 1.5 minus 0.6. So this comes out to, we'll take the LCM and it will come out to be 15, and 15 minus 6 is 9, 0.9. 0.9 volt is the 0.9. So total EMF is 1.5. From 1.5, around 0.6 volt is dropped inside the cell itself, and that terminal voltage which is available to us in the external circuit is 0.9 volt. So cell is of EMF 1.5, but in practical use it is of 0.9 volt, because we can use only 0.9 volt in the outside cell. So if there is an appliance which works on the 0.9 volt, it will work. But if there is a motor or an appliance which works on 1.5 volt and the cell is of 1.5 EMF, but there is internal resistance of 1 ohm, then that appliance will not work, because still voltage across that appliance will only be 0.9 volt and not 1.5, because 0.6 volt is, it is dropped inside the cell itself. Now we'll do our last question. This is the last question of the exercise. So it is a very easy question, 15th question. So suggest the value of R, suggest R, value of R, and the method of connecting it together. We have to find, we have to get equivalent resistance. We want total resistance. We want total resistance. First is, we want a total resistance of 2 ohm, and we want a total resistance of, second is, we want a total resistance of 6 ohm. We want a total resistance of 2 ohm and we want a total resistance of 6 ohm. And from which we want to get? We want it from R and 6 ohm resistance. So, and this also we want from R and 6 ohm resistance. So together, so this is 10 ohm. Want 2 ohm and 10 ohm from R and 6 ohm resistance. Now what is the method? We have to find that R and 6 will be in series or parallel. Here also we have to find R and 6 will be in series or parallel. Now we see the resistance is 6 and this resistance is 2. It means the resultant is less than the 6 ohm resistance. The resultant is less than 6. So if we attach any other resistance in series with 6 ohm resistance, what will be the resistance? It will be 6 plus X. So if it is 6 ohm plus any other resistance R, so the result, what will be the resultant? 6 plus R. But what we want resultant 2, which is less than 6. So we cannot attach it in the series, we have to attach it in the parallel combination. We'll attach 6 and R in parallel. So we'll get 6 and R in parallel, and resultant we will get, what is the resultant? We want resultant as 2 ohm. So here we can apply the equation 1 by 6 plus 1 by 6 plus 1 by R must be equal to 1 by 2. It is the equivalent, it is given. Therefore here the LCM is 6R. So 6 plus R is equal to 1 by 2. So we'll get 6R divided by 6 plus R is equal to 2. 6r divided by 6 plus r is 2. So 2 3s are 6. We get 3r is equal to 6 plus r. So 3r minus r is equal to 6. So 2r is equal to 6 and r comes out to be 6 by 2. So it comes to be 3. So this is 3 ohm. So the value of R is 3 ohm. If we join 3 ohm and 6 ohm in parallel, then the equivalent resistance will be 2 ohm. So this is 6. Now is the second part. This is 6. This is R. We want 10. It means it is greater than 6. So we will get 6 and R in series to each other. So total will be 6 plus R, which is given as 10 ohm. So 6. So R will be 10 minus 6 is equal to 4 ohm. So here value of R will be 4 ohm. And what is the method here? It is in parallel and this is in series. That is in parallel and this is in series. So these are all these numericals are over. So in next video we will do the other numericals from other chapters. So kindly note all these numericals in your notebooks, and if you have any doubt we may clarify in the